So here we have the next lesson, area of rectangle. So you can see that again we'll ask with simple, like we are now moving towards where we are talking about the array. For example, you can arrange them so you can find like array, how many rows are there and how many squares are in each row, or how many columns are there and how many squares are in each column, right? So for starting this concept, we are giving them this prompt, and so that they can odd one out. Basically they are thinking about the attributes, so they can pick anyone out and they can justify why do you think that this is the one that does not belong with others. Okay, so next there's an activity we have to figure out how we can do it virtually. The activity is similar, like they are given a different grid papers and with square tiles like this. They place a file between the students and they make any of the rectangle they want to make, right? And then they describe to their partner, like they cannot, for example, let me read it from here. Partner A, draw a rectangle on one of the grid provided, describe to it to your partner without telling them the total number of squares. Like for example, you have made a rectangle using 20 squares, so you cannot let them know I have used 20 squares. You have to tell them something else, and the next student would have to make the same rectangle. And if you are describing your rectangle correctly, so the person would be able to draw it. So they will switch the role and they can make different things like this. So to do this, what my idea is for doing virtually, either a student can play with computer, I can explain it how, and or they can we can virtually connect students with from different computers within the classroom. So one student can draw something and it can write the descriptions and send it to the student, and then the next student would have that subscription, and then using the description it will create and submit it to. So the student can recheck and the computer can recheck, okay, like it was right according to the given description. And if we are making computer as a partner, so what would happen, like computer will give some description to the student the apart from the number of squares. They can ask, there are 5 rows each with 5 these sort of instructions, and the student will have to draw and check. And also student will draw and he will write some description and computer will create for the student. So student can see whether I can understand the description of any rectangle, or I can also give the instructions so to my computer, so that I can have a student draw the same rectangle that I want the computer to draw. So this could be done like that. Okay, then when they are done with this, when you can see it, it should be time bound. For example, if the students are giving right answers and descriptions are also right, and the computer is also drawing the same thing, and computer is also understanding, sorry, student is also understanding the description and drawing the same rectangle that computer wants to draw, then they can switch to this. And you will ask, what language did your partner, like computer, uses that was most helpful for you to draw the same rectangle. Like you are expecting that it was talking about the length and width, or it was talking about the rows and columns, and that language is too helpful for drawing rectangle. Yeah. Okay, next then the question will appear, find the area of each rectangle and include the units, explain or show your reasoning. For example, you can find there is no tile, you have to count the number of squares inside. So this is basically a grid from tile. Now they're counting the grids and writing the answer, so it is like no that interactive, but it will appear one after the other. Yeah. And for this explain or show your reasoning, we can do this. First you show them this picture and they write the answer, and then you have prompt to explain, and or the tiles will appear, so they can fill the tiles and they can say this is how, this is why I know, or they can also write any descriptive reason if they want to. Okay, let's share how we found the area of rectangle. In the last few sessions, we learned about the area. We learned that the area is the amount of space covered by the shape. Then we learned that we could find the area of two-dimensional shape by counting how many squares the shape covers. We also revisited array today during our warm-up. Here is an array next to a rectangle area. Here is an area different from an array. How do you see equal groups in this representation? Take 5 minutes to respond to one or more of these prompts. Describe area in your own words. Okay, how can we measure area? What lingering questions do you have about area? So this is something that is summarizing of this lesson that we can ask a student to do. Okay, after the summarization, we will provide the answers of all of these by ourselves, voiceover, and then this question will be given in the last. What find the area of this rectangle, explain or show your reasoning. So the same method will be used as we have previously done, but this time whatever the cooldowns are, so in the cooldown the data will be recorded for teacher or for students to see whether they have understood that particular lesson or not. Whatever they are doing previously, it was like learning, and it is like a short assessment. Okay, now from array we are coming towards the product as area. So that's the next lesson plan. How do you see and how do you see them? This is the answer that we are asking. So you can see, what do you see? How many you see? They can see, they can, I can simply see there are 15 dots. And how should they see them? I see them in groups of 3. So they can answer this like this. Okay, what is one way you could describe this rectangle, because they have learned how they can describe rectangles in the last lesson, so they are more like they are this. We can also, what is the one way you can ask for more ways here, like describe at least 2 ways that you can use to describe this rectangle, like how many squares are there and how many rows are there with each, with how many squares in each row, and how many columns are there with how many squares in each column. So there are so many ways you can describe this rectangle. So student can explain any one or two or three. So or if it is difficult for third graders, so you can provide them some sentences so they can pick the one that most suits with the situation. Great. Okay, match each expression with a rectangle that can represent it. Be prepared to explain or you show you, because in the previous task you students have learned what multiplication as repeated addition. So if there are same number of squares are repeating in each row or in each column, so you will provide them some expressions and some rectangles, so they can plug and they can put that expression over the right rectangle. So they will have some rectangles along that fulfills according to these expressions. Okay, then they will answer how do you see factors in each rectangle. So what will happen, one of the expression like this 9, or it will enlarged on the screen, and it will highlight 9 and 5 and write these are factors, and how do you see factors, then this answer will prompt how do you see factors, so they can see they are the sides. Then the answer will be here, 9 times 5 is 45, so 45 is a multiple. Where do you see 45? So it is the area, so they can answer, right? And you can also give them options like factors are size or area, or product are size or area, so they can pick the one. Why does multiplication give the same answer as counting by the one by one? So they have to write the description here. So it may be difficult. If voiceover is possible, so they can record their voice to submit the answer of this question. If computer can check, it's wonderful. If it could not, then we have to rely on teachers. Okay, the number in expression represent the number of rows in a rectangle and how squares are in each row. On the grid draw, now what they have done, in the previous task they have matched the expression with the rectangle. Now they are actually drawing. So again it will be like a geoboard. They can use it and they can draw and they can submit. Computer can check whether the answer is right. Explain why multiplying the numbers in the expression gives us the rate of the rectangle. So they have already explained it. Okay, so what they have done here, they have to justify, like for example which color they are using. Like for example, if they have 3 times 4, so they have created rectangle. So why do you think that this is the right rectangle? How they can justify it? So I think it will be a tough task for virtual. So we have to be very selective how we are asking for reasoning. How can both of these rectangles match the same expression? Okay, where are these two rectangles? Here the expressions are missing, I think, but so we can draw two rectangles here, like 3 times 5 and 5 times 3, and they can give wow how the rectangle matches the same expression. So you can see they can flip that rectangle like this, and they can see they both are just the same. So they can answer this like that. Okay, how could you figure out the total number of squares in this rectangle? So they can easily just multiply the two sides. They can say this is 7 times 2, and they can just write the expression. If you can ask to write them expressions, so they will write it. How are the rectangular area if similar to the other ways we have shown multiplication, so they can just count. Here are rectangular area different from other we have shown multiplication. Okay, so this is the last cool down or assessment of this fifth lesson. And student would have to use this rectangle to create a rectangle that matches with this expression 7 times 4. So they can create a rectangle of their choice. So this is how I have just explained you the 5 basic lessons, and they are very easy. We just require square tiles and just drag group so that they can fill, computer can check, they can draw grid like geo boards. So this is the basic requirement here so far, so we can do it. And we can use the same question bank, and then after completing all of these courses there will be a test, there will be a sort of checkpoint where student can appear and they can answer. Let me show you how it works. Okay, I'm back to school yourself, and I would show how they have aligned resources. For example, you can see we were looking through this interactive learning resource at the start of my first video. Now you can see how they have organized. This is intro to area, and this is lesson, and this is you can log into practice. So if students already practice, so when completing this course, student can complete all the course like brilliant.org, and then they can appear to do something practice. So there will be practice questions like IXL, but it will be interactive, whatever sort, like real tile will be provided. Like for example, these sort of tiles could be provided to them, then they can just align them. It should be that very easy to handle. Like for example, you just get them close and they are aligned properly, so they can use these tiles to answer of the many of the questions. And sometimes when they struggle, so they can use these tiles. When they don't struggle, they can easily answer directly. And when they will be working in these tests, so the data will be recorded and it will be shared with teachers. So there is a package where students are first learning that concept, that as I have shared you in lesson plans, and then they will practice like IXL. So but it will be more than IXL, like it will be like interactive like these of the resources. Okay, so this is the first plan. I think it will be enough so that you can start your working, and I can then share, we can come up with something. How long will it take to cover more of the things? Thank you so much.